Let's take a look at one more example using the elimination method. So here with example 4, if we try to use the elimination method right now, you'll see that neither of our variables will cancel. So when something like this occurs, we need to make some changes. Now for example, let's say we want to cancel out our y variable. We need to change this coefficient of -2 and this coefficient of -3 to be the exact same value, only that one is positive and one is negative. And when that occurs, then they'll be able to cancel out when we add them. Now in this case, it looks like we're actually going to have to multiply a constant number to not one equation, but to 2. For example, let's say we want to eliminate our y variable. So in order to do that, we need to change it so that this -2 coefficient and the -3 coefficient change to where they're the same value but opposites, so that they'll cancel out. So what we need to do is change them. So one way we could do this is to find their least common multiple. Now for example, with 2, we could start listing its multiples and see if it has a common one with 3. So multiples of 2 would be 2, 4, 6, 8, and so on. Now if we did multiples of 3, we'd have 3, 6, 9, 12, and so on that way. Now if you notice, the first multiple that they have in common is 6. So what we could do is we could change each of the coefficients for y to have as 6, but one will be positive and one will be negative. So let's do that. So let's say that we want our first equation to have the positive 6. So in order to change a -2 into a positive 6, we need to multiply the entire equation by a -3. Because -3 times a -2 gives us a positive 6. And then similarly, if the top one is positive 6, we want the bottom equation to have the coefficient of -6 for the y variable. So to change the -3 to a -6, we just need to multiply by 2. Because 2 times -3 is -6. So now let's actually do the distribution for this multiplication. So a -3 times 4x gives us -12x, and then -3 times -2y gives us a positive 6y, and then the -3 times positive 16 gives us a value of -48. So here's our new version of the first equation. Now let's do the same thing for the second. So we'll first do the 2 times 3x, which will give us a value of 6x, and then 2 times the -3y gives us a -6y, and then 2 times 15 gives us a value of 30. Now we're ready to do the elimination. So we can add both these equations together, and -12x plus a 6x will give us a -6x, and then a positive 6y minus a 6y will cancel to give us 0. And when we add the -48 to the 30, we get a value of -18. So now after we do this addition, we're left with a -6x equals a -18. So to solve for x, we just need to divide both sides by a -6. Now that leaves us with our x equaling a -18 divided by a -6, which the negative divided by negative will give us a positive 3. So we know that the x value to our solution will be 3. Now if we want to find the y value, we just need to plug the x value into either one of our equations. So let's try the second equation. So we have 3x, where x is 3, minus 3y equals 15. So when we simplify, the 3 times 3 becomes a 9, and then we still have the minus 3y equals 15. So from here, in order to solve for y, we need to get rid of that 9. So we'll subtract it from both sides. And that leaves us with a negative 3y equals 15 minus 9, which is 6. And then now from there to isolate y, we need to get rid of the negative 3 by dividing it. And that leaves us with y equaling a 6 divided by a negative 3, which gives us a value of negative 2. So for this system, the solution will occur when x is 3 and y is negative 2. And again, if you'd like, you could write that solution as an ordered pair. Now that we know the substitution and elimination methods, let's take a look at a few special cases that can happen when we're solving linear systems algebraically. So let's take a look at our first example. So here we have y equals 2x plus 1 and 2y minus 2 equals 4x. Now that we know both methods, we could choose to use whichever one we want. Now it looks like the easiest one would be using the substitution method, because we already have a variable isolated. So since y is equivalent to 2x plus 1, we could just plug in 2x plus 1 for our y value in the other equation. So let's do that. So we have 2 times y, where y is 2x plus 1, and then minus 2 equals 4x. So now let's simplify a little bit. So when we distribute, this 2 times 2x will give us a 4x, and then 2 times 1 will give us a positive 2. And then we bring minus 2 equals 4x. Now let's simplify some more. So we have 4x, and then plus 2 minus 2. Well, plus 2 minus 2 is just going to leave us with 0. So then we have equals 4x on the other side. Now if you notice here, we have 4x equals 4x. Well, those are the exact same thing. So no matter what we do, we're still going to have the same exact answer on the other side. For example, if we divide both sides by 4, the 4's will cancel and we're left with x equals x. Or if we subtract the x's on both sides, we're left with 0 equals 0. Now, when you're solving for a linear system, and you end up getting a true statement like this, whether it be 4x equals 4x, or 0 equals 0, or 2 equals 2, it indicates that the two equations in your system are actually the exact same. So if you were to graph them, they would produce the exact same line. So when something like this happens, it means that there would be an infinite amount of solutions. Now let's take a look at another special case. So here with example 6, we have another system. Now if we want to solve it, it looks like the easiest way would be doing the elimination method. Now here with example 6, it looks like the easiest way to solve this system would be to use the elimination method. Now we can't just add them up right now because neither of the variables will cancel. So we need to make a slight change in one of them. So for example, let's say we want to cancel out the y's. So in order to do that, we need to make one of them negative. Since they're both a positive y right now, let's just change the second equation to make it negative. So we'll multiply everything by negative 1, which will change the second equation to be a positive 3x minus y equals 1. So now let's bring our first equation in again. So the negative 3x plus y equals 4. Now let's add them up. So 3x minus 3x will cancel to be 0. And then negative y plus y also cancels to be 0. And then we're left with 1 plus 4 equals 5 on the right side. So here we're left with 0 equals 5. Well, obviously that's not true. Now when something like this happens when you're solving a system, it's an indicator that the two equations in your system are parallel lines. Or in other words, they'll never intersect, so there won't be a solution at all. So when something like this happens, you know there is no solution.